Hello everyone, this is your lecturer Ahmed Zubaidi. I'm the lecturer for the manufacturing engineering in the spring 2018. As a part of this subject requirements, you have to do a hands-work project, which is the manufacturing of the water pump. Through this slide, I'm going to give you a hint about the design procedure of the hand pump, which is going to be done as group work, where every group have to build their own pump, which is going to be tested on test rig available at the B4 lab for the manufacturing engineering. So before we are going to start that, we have to remind you that you must have to complete the UTS online laboratory and equipment safety inductions. So simply you have to go for a walk and identify the location of the following in the lab: where is the emergency phone, where is the emergency exits, where you can find the first aid kits, where are the emergency showers and the eye wash stations, where you can find the spill kits, and what you can find the antibacterial dispensing stations, and finally the equipment emergency stop button. Well, I'll try to be with you in the lab during the first session, which is going to be run in the week, starting from the week number 3. So once again, just to remind you that the location of the mechanical design studio is going to be at the building 11, the same building we have the lecture on. It's going to be at B4, where you can use the elevators 1, 2, and 3 to reach the basement 4, and the room number is 109. So once again, in the event of the emergency and your lab supervisor is not available, you are going to dial 6 to contact the security in the case of emergency. You have to remember that you always have to return the tools to the designed storage areas, and you always have to keep the floor area tidy and free from the obstructions. And always clean up the area once you have completed your activity. Always wear covered footwear when you are going to be in the lab area. By the way, the lab observer have the right to restricting the entrance to the lab if you don't have covered shoes. Always wear the eye protection when operating tools or machinery, or when the vicinity of someone using the tools or the equipment. Always conduct yourself professionally when working with the area, and report any bullying, sexual harassment, and antisocial or dangerous behavior. You have to remember that no food or drink are allowed to be consumed in the lab area. Always you have to wipe the lawn safety glasses with the antibacterial wipes before using them for your own safety. And also you have to report any damaged machinery or equipment to your supervisor or tutor immediately, and you have to use the lockout and the tag kit if necessary. Make sure that your tutor or the lab supervisor instructs you in the correct operation of any machine, tools, or equipment. And also you have to address your lecturers, the tutors, and the supervisor appropriately. Always be punctual and start the packing up at least 15 minutes prior to the conclusion of your session. And always wash your hands after each lab sessions, and label and store your pump parts in the designed storage locker. So for the water pump project, the project is going to include the research part, the plan, the design, the procure, the manufacturing, and the test. You are going to have a test rig, you are going to have the raw material, and you are going to have deliverable workshop accesses. So that's what is going to be available for you, and that's what you have to done in red. So if you don't know where to start from, you have to ask yourself the following questions. First, what is it? What the pump is? Second, how does the pump work? Okay, now I think that most of you did physics in high school. Well, let's start from the point number 1, what the pump is. Well, the pump is a device which can simply well, from the name, is going to pump the water from the lower level to the high level, or sometimes is only going to increase the pressure to increase the velocity, and thus we can send it to a longer distance. How it does work? Simply is going to work by using the negative and positive pressure procedure. So as you can see in this diagram, starting from the first image, the first part on the left side, on the right side, sorry, you can see that the water will get in as we're going to generate a negative pressure inside the chamber. So you can see that below we have the what actually is going to be the seal, is going to, the valve was going to be opened as we're going to generate the negative pressure between the piston and the cylinder, and this will attract the water in, and after that we are going to push the piston down, and this will close the lower valve and opening the second valve, which is going to be within the cylinder, and thus the water will be simply going to be pushed up to a higher level. By repeating the procedure, we are going to continuously pumping the water. So the other question is, how many parts are going to need? Okay, how many pumps I have to manufacture? Well, actually this question is going to be about the part of selecting the material and the cost of the material at the end. Now usually you know that if I'm going to manufacture one part, is going to be more expensive than manufacturing multiple parts. This is simply going to be considered about the setting up of the manufacturing process and the requesting of the raw material. The other question is, how long does it need to get last? So if you're going to make something, you should consider that the long lifespan is the better. You shouldn't do something that is going to be disposable. I'm not going to use this thing once and then I have to bring another part. Now if I'm going to make a product, I should always design it to last longer. So usually again, to move back and forth through the 4 manufacturing strategy questions until you come up with the solutions, which is what is it, how does it work, and how many do I need, and how long does it need to last. Now the things you have to start doing before you go to the lab in the week number 4 is going to be the making of the hand sketch. You have to make your own design before you go into the lab and start to think about the new design. Well, we supplying an engineering drawings. Okay, this is an example of the engineering drawings we supply for you. Okay, this is the pump design. Now these are the multiple parts. You can see that the names of the parts are mentioned to the table to the left bottom corner. So we have the pump main body is the number 1. We have the pump shaft main is the part number 2. Part number 3 is the pump handle. We have the main piston is part number 4. We have the 6mm nylon nut is the part number 5. Part number 6 is going to be the foot valve, and part number 7 is going to be the washer, and we have the small washer, part number 8, and part number 9 is going to be 6mm nylon screw, and we have the part number 10 is going to be the PVC junctions, and we have the cup, which is part number 11, sorry, and the last part is part number 12, which is the junior socket. So the part individually can be shown in the following drawings. So you can see that we have the 38mm internal diameter cylinder, which is going to represent the pump main body. We do have the pump shaft main. We do have the drawings for the pump handle. We do have the drawings for the main piston. We have the drawings for the 6mm nylon nut. We have the drawings for the foot valve, the washer is small. We have the 6mm nylon screw, the PVC junction, the cap, and the junior socket. Okay, so all these raw materials actually is going to be supplied to you by the school. The only thing you have to do is you have to play with the design process. Now, for example, for the junior socket, for the cap, for the PVC junction is going to be an off-shelf item, so you only have to use what you have. But simply you can do some modification, for example, for the foot valve. What else? The main piston. Okay, now you can simply change the washer type. Whatever the thing is going to increase the pressure, and thus is going to increase the massive flow rate you're going to have by your pump. The following sheet also is going to be supplied to you. Is going to be more detailed than the one we had in the presentation we had earlier. So in this one is going to show you the background of the pumps. So simply we know that the fresh water is essential for life, and there is enough fresh water everywhere on earth. But the problem is on how to get the water for everyone. Now, most of the countries actually, they have a lack of the fresh water, and many people actually are dying because of the water lack, actually the clean water lack. We can dig a well, but simply we have to get something to pump the water out of the well. So the challenge we have is, for your project, is going to be to work in a team environment and develop the pump system that can pump the largest amount of the water within a given time frame with the least amount of power. So simply the test rig we are going to have is going to be a motor which is going to be actually taking the handle of your pump up and down and pumping the water. It's going to run at a constant speed for a certain time, and by the end we will check how much water has been pumped by your pump during this limited time and how much power has been used. Okay, now definitely the pump which is going to pump the largest amount using the least amount of power is going to be the winning pump. So once again, the project overview is going to be: first, the pump will need to be fabricated under the manufacturing constraints below. We are going to have limited skill set of students and able to complete it within the normal scheduled lab sessions. There's going to be 3 sessions. Each session is going to run for 2 hours. This will be the practical sessions, including 1 of 2 hours test and the assessment sessions. Of course, the first session is going to start at the week 3. The construction will be based simply on team competing with each other, and a test rig will be simply adopted to automatically run and test the hand pump. The access to technical staff for advice and the assistance will be available during the lab sessions only. Now we're coming for the part of the construction of the pump. The students simply going to be required to form teams and nominate a team leader who will be responsible for the managing the projects and the delegating the task to individual members. The general hardware and the raw materials like the PVC pipes, the fittings, the PVC rod, and the aluminum rod will be simply supplied by the school. Access to the basic hand tools, the drills, the lathe, and the cut-off saw are also going to be available. The teams are going to be free to produce their own hardware if they are going to be prefer that, and to construct their own project off-site. The student must use a PVC nominal diameter of 40 millimeter, that's for the outside diameter, which is going to be the standard drainage pipes. A maximum stroke of 100 millimeter maximum, and you can have the what we call the plus minus 5 millimeter longer or lower, which are the tolerances. A 25 millimeter long M6 thread is going to be required on the end of the piston shaft for the connection of the test rig, and also the size constraints are shown in the figure number 1, as you can see. So the maximum is going to be 500 millimeter. We are going to have 190 millimeter plus minus 5 millimeters for the retracted part. Now the assessment is going to be as following. First, the fabrication and the run of the pump, which is going to weigh 50% of the total marks for this task, where each team will have simply a schedule of 10-minute assessment sessions, including 5 minutes for the setup. Once the test setup is going to be completed, the pump will be run for 2 minutes with the flow rate, pressure, and the power readings taken every 15 seconds. The parameters to be measured, including the start of flow, are going to be the water weight, the current value at 1 minute, and also the flow rate in liter per minute. The total average will be simply recorded, and the team ranking will then going to be derived. The scale mark of the pump test will be simply calculated based on the team ranking. And in the event of the catastrophic pumps or the test failure, a second attempt may be allowed, and the 20% penalty will be applied to the test score. So for the last point, you have to be sure that your pump can work properly, and you are going to have a good design which is going to be an anti-fatigue failure, which is going to be prevented. Now, another 50% weight is going to be given for the written project report, and where each student needs to organize his or her written project report individually by the addressing of the criteria and the marking criteria for the project report of the manufacturing engineering. The marking criteria for the project report is available on UTS Online, and there is no strict limitation on the page number of the report, and as a references you are going to have 15 pages may be suggested if the A4 paper are going to be used. You have to use the normal margins and single line in space and the Times New Roman size font. The reports needs to be document each team member contribution, the calculations, the test results, the material list, the engineering drawings of all the components, and photo of the assembly drawings and the exploded parts, this with the references and labels. There is no limitation to the length of the report, as we mentioned earlier. The report will need to be submitted through the UTS Online as an electronic copy, and you can simply find the links for the submitting of the reports, again to be available on the folder of the assessments on UTS Online. Now, when to submit, simply again to click this spreadsheet which is available on the UTS Online, which is going to show you the due date for each assignment. Okay, now I hope that you understand what the project concepts are, and if you have any questions, simply you will be able to discuss that with myself as well as with your tutor during the lab sessions. But once again, just remember that you have to have the preliminary design of your pump before you go into the week number 3. Actually, start to create the teams from the week number 1, so you're not going to lose time to start your project, and you can simply finish it within the design 3 weeks for this task. Thank you very much, and enjoy the rest of the day.